Alright, looks like I'm recording. I got on the bench today a A1466 MacBook Air. I'm not sure if this is a 2015 or a 2017, one of the two. The issue is, has a green light on the charger but doesn't turn on. So we're going to turn on the power supply. Plug in our trusty MagSafe cable and see what it draws. Current. Alright. 18.5 volts. Turn it on. Alright, so we have an orange light on the MagSafe. I'm drawing 34 milliamps. So obviously it's not turning on. We need to find out why. So we're going to go ahead and take off this cover. Turn the board around. Screwdriver out. T5. T5 and a P5. Oh, gotta get our screw box. Screw box here. Oops. Take out the 10 screws on the bottom. Took off the bottom. Get out our trusty multimeter. We'll do some looking around here. I don't see any corrosion or anything. Oh, and the battery's unplugged, so we are drawing 34 milliamps with the battery unplugged. So we'll go ahead and put the power on again and test some power rails here. Got our multimeter set on voltage. We're going to check our G3 hot rails. We've got our PB3V4 too, obviously, because we have MagSafe light. So let's check PPBUS. 858 on one side. Oh, and 0 on the other. Okay. So we have 0 volts on one side of our PPBUS fuse. 856 on the other side. Do we have a short? Yeah, 4 ohms. So we have a 4 ohm, 3 ohms going down, 2 ohms short to ground. So we have a short on this line. So we have a short on PPBUS. Alright, which means we're going to take this computer apart and fix it. Oh, this computer's never been worked on. DCN cables. Still have the adhesive. Oh, this still has adhesive too, so we'll try not to ruin that. I like leaving them. So we have a short on PPBUS. Safely tuck their SSD away. Before you start removing things like the LCD cable and all that, it's good to unplug the battery just to be safe. You don't fry the LCD. But obviously my battery's already unplugged. I know this. Otherwise I would have unplugged the battery first. It's just a good practice to unplug the power before you start ripping cables out of things. Especially on the newer MacBooks, if you don't do that, you could short out the LCD and things like that. Alright, go ahead and remove our antenna cable, and our screen cable and everything. Gently remove our speaker cable. Gently pry up on the connectors for the Wi-Fi. On the connector, the metal part, not on the cable, because these little cable ends are so easy to rip off, it's not even funny. And we put all of our screws in an organizer so we don't lose them. We don't get them mixed up because they all go in a certain place. I've taken I don't even know how many of these apart, so I know where the screws in MacBook Airs and MacBook Pros go, but if you don't, it's a good idea to keep them separate. So it makes it easier and quicker to put it together. Alright, I think we're ready to come out. Oh, the keyboard and the backlight cables. Flex cables here. Come on, you. Come on. Out you go. Alright. Board is... Come on. Our board is ready to come out. Really? Fight. Okay. I see no evidence of corrosion on the back side of the board. So as you can see, the mask for the keyboard backlight is nice and shiny, no damage, no liquid or anything. So we're going to go ahead and look on the back side of the board. I'm going to put the microscope in the way for a minute. See if we can find anything. Backlight looks good. No liquid damage around the SMC at all. Looks good. Everything looks good. So I think I'm going to power the board on because I know. Let's open our schematic really quick for what board is this? So 00165. So it's either a 2015 or 2017 board. 00165. And our PPBUS is shorted on pin 2 of F7140, which, if memory serves me, is the system side, not the creation side. I'll be able to tell that if I find my PDF. Where's my PDF? There it is. PDF is hiding it behind OBS. Alright. Pin 2 is the system side, yep. Alright. So, we're going to have to remove the fuse and check for a short. And then if we cannot obviously see the short, we're going to have to inject voltage. To find our short, which is always fun. I like doing that. I think it's fun. Where is Flexboard view? PPBUS comes from U7100 on pin 1 of F7140 at pin 1. Let's move this. Pin 1 of F7140 is on this side. Is on the right side of the fuse. Yeah, so that comes from the ISL6259 from inductor L7130, which is the big inductor right above it, which comes from pin 23, charger phase from U7100. Yep, charger U-gate. Yeah, so charger U-gate, L-gate goes through Q7130 and L7130. So Q7130 is this dual Mosfet package right above L7130. And that L-gate, U-gate go from the ISL to this chip and then through this inductor into the fuse and then out the fuse to the rest of the board, to all the other spots, like the backlight circuit and everything. The backlight circuit uses PPBUS through U7701 boosts PPBUS, creates 25 volts for the backlight. It also goes to via F7700. It also goes to where else? PPBUS goes to Thunderbolt, I think uses it, and that's it. Yeah. So anyway, we're going to pull this Wi-Fi card off because we don't want to burn that, and we can get rid of the fuse, check for a short again, and then if it's got a short, we'll inject some voltage on this board. And some alcohol and see if we can find our short, see if something gets hot. We got to replace the fuse anyway because the fuse is blown, so go ahead and remove that. my lights flicker a little bit because this thing is so powerful that it, and I've got the hot air station plugged into the same outlet as my light, which I would like to remedy that. I would like to plug my light somewhere else. Have a feeling it wouldn't matter. Come on, little fuse. Alright. Fuse is off. So let's check again. Yep. We have a 200 milliohm short to ground, so that's a dead short. Other side. Nothing. I mean, no short. Ooh, forgot that's hot. Touch that ding dong. So, once it cools down, it'll probably register something, I imagine. Mega ohms. Anyway, we already know that it's short, so we're gonna go ahead. We're gonna go ahead and inject. We're gonna turn the other power supply on. And we will inject some voltage. So, got one of these ground clips, ground leads, so I don't have to do two solder joints on the board. I can just hook this to one. So that way I'm not making a complete mess of the screw holes to ground out. And actually I've got a new one I want to try out. I've got one that's got an alligator clip on it. There's like these big ones, so yeah, that'll make a nice good ground. But I will have to solder the positive lead, which is fine. Got this nice fat ground lead here we can clamp onto the ground. Some more solder here. We're going to start off real low with probably 1 volt, 1.5 volts. 1 volt at 8 amps, so that'll be 8 watts. So if something is shorted, it'll draw 8 watts, will burn up in a hurry. Now, I do not suggest anybody does this unless you know what you're doing, because you can easily ruin a logic board and cost your customer $300 plus $360. Have to buy them a new logic board if you ruin this. But I've done this hundreds of times. I've fixed boards hundreds of times. I've only injected voltage 30, 40 times. So we're going to set our power supply to 1 volt, 8 amps. So, alright, and we're going to turn this bad boy on and see what happens. There's our, get some alcohol here. Alright, 3 watts. So something should be getting really hot. We're drawing 3 watts of power. Something should be boiling. Don't see anything yet. Oof, 3 watts. That, whatever it is should be on fire right now. I gotta be very careful because 3 watts will burn. Is it or ISL? Whatever it is should be sizzling. Yeah, 3 watts. It's not our CPU, thankfully. Was it just the fuse? Alright, I'm going to have to put the microscope in the way because I'm not seeing anything boiling here. And 3 watts. I should, like, something should be sizzling. Sizzling hot right now. Kind of can't see with this wire in the way. First, we're going to look at our usual suspects. PPBUS caps. Hopefully the board doesn't have an internal short. That would not be good. Huh. Three amps, man. Should be on fire right now, sizzling. Not the CPU. Dang, do we up it? 3 watts. Like, whatever it is should be sizzling right now. Should be boiling. I really don't want to touch anything. milliamps, or still 3 watts. Something on this board is dissipating 3 watts. And I can tell you that if I touch it with my finger, I'm going to find it. And our PCH, our CPU is not hot, so that's good. I'm going to go up a little bit in voltage here. Go up to 1.5, 1.2, 4 watts. No explosions yet. 4 watts. So I must have interesting, so maybe just the PPBUS cap blew. No, it can't. There's a short on here. There's a short somewhere. Because if we look, PPBUS G3 hot goes, so it goes to F7700. Goes to F7700, goes to Q3080, nope, Q3080. Not anything over here. Some other components over here that go to nothing bubbling right now. think our CPU is getting warm. That's not good. Let's go ahead and turn the power off real quick and test. See if our CPU is shorted to ground. Oh, that's no good. RIP. The CPU's dead. I got a 0 ohm short to ground on PPBUS CPU. Oh, not good. Not good. Well, that was a waste of time. Oh, bummer. Yeah. RIP. .5 ohm short to ground. CPU's dead. Alright, well. But this is now a donor board because I can't fix it. The CPU is most likely toast. Now I could start pulling off Mosfets and stuff. In fact, I may pull off the heatsink and see if these Mosfets down here are boiling. But at this point, really not much we can do. But if I up the wattage, if I up the current and everything on the power supply, sooner or later the CPU is going to start getting hot because it can take a lot of heat or a lot of wattage. I mean, I could probably go to 80 watts. I mean, I'm sure the CPU can't handle that much, but let's at least try. Look in the microscope at those Mosfets and see. Really do is clean the PCH and the CPU off really good and put some alcohol on that, and if it starts boiling, then that's where our short is, unfortunately. Alright, we're gonna put some flux back on here and put the solder the jumper or solder the wire back on here. Ground in again. Get the camera out of the way, or the microscope out of the way. $4 watts. gonna put a little tiny bit of alcohol in here. Oh, hello. I think, wait a minute. We might have found our problem. Yep. No way. Ha! No way. Hey, not so fast. The CPU might not be dead. I think I see bubbling. It's a Mosfet. Oh, ladies and gentlemen. Won't counter out yet, just yet. Yep. Ha! Found the problem. Sweet. This board might be fixed or fixable still. It's not down yet. Alright, let's desolder this wire since we know what's bubbling now. It's not the CPU, so the CPU might be okay. Might be able to save the old girl after all. So that is Q7310. Q7310. Come on. Which is on phase 1. Which is on phase 1 of our CPU V-core. It's a V-core power stage phase 1 transistor. So it might have killed our CPU. These two MOSFETs, there's U7310 and U7320. It's phase 1 and phase 2 CPU VR 12.5 ECC power stage MOSFETs. So they go through inductors and then they go up and put out 1.8 volts for CPU V-core. I mean, if it was stuck on, then it could have sent 5 volts to our CPU possibly, which might have killed it. But we don't know. So let's tear it off and see if we can fix it. What we'll do is we'll desolder it. We'll desolder and check for a short, and then if our PPBUS is no longer short, then there is a chance that our CPU might still be good. Oh, you know what I didn't think of? I wonder if phase 1 and phase 2 are connected. Probably. Yeah, they're connected to the same caps. So phase 1 and phase 2, let's measure it. I'm curious if phase 1 and phase 2 would both be short, because that cap up top that I measured, or the inductor that I measured up here, is phase 1. So let's try phase 2. Yeah, so they're both showing short. So if I remove this, our short should be relieved. And if it is, we might still be in business. Couldn't see because those two power stage MOSFETs are under the heat pipe of the CPU heatsink, so they're hard to see. That's why I couldn't see where my short was. But sure enough, after I removed them and put more alcohol on the board and turned the power back on, it was bubbling. We're not going to give up just yet. We're going to try and see. We're going to put a new MOSFET on here and see if this board's still fixable. pinky. Alright, remove said bad Mosfet. Let's see. Nope. Oh, sad. I removed the Mosfet. It's still short. We still got a short. So do I inject voltage again? And see if there's something else that shorted? Well, I guess if the CPU gets hot, then I'll know. Then I'll know that it's shorted. That our CPU is done for, which is looking like the case. So let's inject voltage again. We're not drawing any current anymore. So wait a minute. Might not clip to ground here very good, or it's not drawing anymore. It's not drawing any more current. So I mean, I removed the bad Mosfet. Let's pull this, unhook this wire, and see if we're still shorted to ground. Oh, we're showing 28 kilo ohms on PPBUS now. Huh. Alright, well. Oh. Yep. I think the CPU is toast. Unless something else is toasting. No, it's not drawing any current anymore. What if I remove the inductor? Oop. Turn the power off here. Yep, I think that Mosfet blew up and killed the CPU. So I'll remove this inductor. And if I remove this inductor and it's still shorted, then it's kind of pointless. So I bet that's what happened. I bet you that Mosfet stuck open. Instead of turning off and turning on, turn off, turn on, it stayed on and sent 5 volts to our CPU, and that's all she wrote. Goodbye PCH. Come on. This thing does not want to come off. so it goes. Basically, they go through these MOSFETs into these inductors, through these resistors, and then right into the CPU. So I wonder I can test V-Core PPBUS CPU right here in between the CPU and these capacitors, because then that'll rule it out for sure. On any of these little caps here. So wait, let's pick one. We'll pick the top one. Well, there's no top one. We'll pick this one. So the bottom pin is ground. So that's 0. Yep. Yep. RIP CPU. Dead. Yep. There's a 0 ohm short on these capacitors. That's right in between the big resistor and the inductors that are in front of those MOSFETs. So our CPU is toasty oats. Yeah, charger phase 1. Sad. RIP CPU. Alright, well, this poor board is DOA, is dead on the operating table, unfortunately. So I guess the stream is over. There's really nothing else I can do. Yep, the CPU's hot. Yeah, CPU's really hot. So it's still getting current from the other phase. So if we turn this up a little higher, no, it won't. It's not gonna work. Take that back, because we'd have to put the MOSFET back on and stuff. So the current would go. If I put a brand new working MOSFET on here, all it would do is probably work and send the 1.8 volts to the CPU, even though the CPU is shorted, and it'd probably just blow the PPBUS fuse, which in turn would probably below the Mosfet. So guess we'll just tidy it up, put it back together, and see what the customer wants to do. So bummer. Happens once in a while. Not a lot, not very often, but it happens. So anyway, that's it for this video. Hope you learned something. Thanks.